Hey everyone, today we're going to talk about a really fun and exciting implementation of auto self-tuning, self-improving GPT script, which is going to create its own data set, tune itself, and then continue iteratively tuning itself to see how good it can get at tower defense games. Let me go ahead and start the script, and then we'll talk about the code review, take a look at the data sets and what it can and cannot do. So this is pretty exciting. As you see, the first thing you notice is that we are actually resubmitting the test due to sorry, apologize, however, because, GPT 3.5 sometimes says, I'm sorry, but creating a tower defense game is out of the scope. He sometimes apologize. Sometimes says, however, I suggest the plan or something like that. So we are actually eliminating those responses and only putting into our data set the produced responses. As you see, we are currently generating the data set. And when we reach 10, then we are actually going to start the fine-tuning process. Currently, it's being started, and currently the files are being validated. After that, we'll be able to take a look at the progress. In the meantime, let's see how this all works. Currently, the files are being validated. We can see the fine-tuning job will be starting shortly in our playground. We will be generating 10 dataset points each time, just like this. Total of 10 points, which is the minimum required to fine-tune GPT 3.5 Turbo. And we will be repeating this process 10 times, meaning we're going to fine-tune original GPT 3.5 Turbo base. Then we're going to get the name of our fine-tune model and continue fine-tuning iteratively on top of that. So this is going to be a time-consuming process. While this is ongoing, let's talk about the code and see what's possible. We are going to generate data sets each time, and we are going to have some kind of criteria. For example, we're going to refuse the ones that include the word sorry, apologize, and however. Then we are going to create our first data set. Here we have done that. And as time goes on, as we move on to the second iteration, these data sets will be moved into their own respective folder, all data sets, and they'll be accumulated here. I will actually go ahead and delete that so we can see that happening in real time. So what can this achieve? Well, I'll show you quickly. I have some examples here. So normally if you ask GPT, even GPT-4 to create a tower defense game, it's just not going to be able to do a very good job. Not only that, it's really difficult to get code out of GPT that is more than like 200 lines. And with a fine-tuned model, I was able to get 372 lines of code here, for example, for a tower defense game, which required only minor adjustments. And if I run this real quick, running it from a new terminal, we can see that it has created some kind of a complex game, which doesn't work, but it's allowing me to place towers and my money is being deducted. Normally speaking, you wouldn't get any of these extra UI elements or anything like that. So this is one. I mean, this is first to explain that. I mean, I couldn't believe that we are getting almost sometimes over 400 lines of code. Here is another one, which is actually 200 lines of code. Let's run this one. And as we see, we have like some score and we can place towers. We just ran out of money, except we're not shooting, right? So this actually kind of works again. That's why I said this is a kind of success. And another one is like this one. If you take a look at this, I mean, this is 500 lines of code written. It doesn't run. I mean, but to be able to get GPT to output 500 lines of code is, especially 3.5 Turbo, it's pretty significant. So I had tried it up to 5 iterations. So in this video, hopefully we'll try to go up till 10. Okay. So while the fine tuning is taking place, and it's actually being slow today, I restarted the script a few times. That's why we're actually interested in the last one. It still says it's validating files. In the meantime, we can review the script and see what's happening here and how we can achieve auto self fine-tuning GPT system like this. Before I continue, I just want to say that the code files for this will be available at my Patreon at AI connoisseur level. I also, if you become a patron, you will have access to 160 plus exciting files, project files, including the Everything GPT course, implementation of MemWalker, AutoGen Deep Dive, and many other exciting projects. I also host office hours almost every week, so you can join those as well as a patron. And I create exclusive deep dives for patrons as well. You will also have access to those videos. If you want to find out what projects I have, you can go to my website, www.ecohive.live, and quickly browse through all 200 plus of my projects. And you can also make searches, for example, for AutoGen. It's a real-time search. You can find the descriptions, and if you're a patron, find the code download links. Now let's go back to reviewing the code. First, we are having our imports. The requirements for this is OpenAI and Pygame. Pygame so that we can actually test the game that GPT is producing. We are importing time because we are going to run a loop to keep track of the status of the fine-tuning job every 30 seconds, because after it succeeds, we want to grab the model name, the fine-tuned model name. That's why we are importing time. We are importing shuttle to move files. We are going to move the data set. Once it's done, once the fine-tune is done, and move it into the folder all datasets and create a new one. We are importing concurrent.features because we are going to use thread pool executor to parallel process the dataset generation. Since we are creating 10 at a time, we are going to create them simultaneously. Okay, so we are defining a class called fine-tuner. And our starting model is going to be GPT 3.5 Turbo. We are setting our OpenAI API key either from our environment variables, or you can enter it right here in the script. So our model is starting model. The system message you can actually manipulate to serve any purpose. Here in this case, it's a tower defense game, but to adapt this to your own purposes, all you have to do is change the system message and the user message. Here our system message says you're a world expert in writing tower defense games, and the user message is create a fully functional tower defense game using Pygame. All game assets are created in game. Don't use any external files as assets. No sound is necessary. Write the whole game in a single Python code block. Don't give any excuses. Just write it as best as you can. The reason I added this line because he kept saying it's too complicated. I'm just an AI language model, you know. But we added a dynamic programmatic check for that anyway. So if you want to change this to fine tune for any other purpose, just modify these two messages and that's it. Then we have a method called generate completion, which is going to call OpenAI and just generate the completion. We are keeping the temperature high, so we get varied results. Our system message goes here, user message goes here, which we have defined up here. We have streaming through, just in case if you want to print it out while the generations are being done. Makes tokens set to 3800. I'm just giving some room for these. I want to get as much as possible. And sometimes actually it generates over 500 lines of code, which doesn't fit into the context limit. So it's really interesting. This loop is for creating extracting the chunks tokens as they are generated in streaming responses. You can uncomment this line if you want them to be printed to the terminal. And we have another method called save the file, which is going to take in the completion and iteration. Completion is in the response, right, from GPT, and write it to file, meaning it's going to write it into the dataset file by appending it. Okay, so we are taking the iteration number so that we can name the files appropriately. Here, as you see, _1, and data format has to be like this for fine tuning. Messages is a list of roles, right? Our system message, our user message, and our whatever the assistant returns. So this is going to comprise of a single data point. As you see, this is a JSON object, which consists of a messages list, which in itself contains a dictionary up until here. It includes the system message, our user message, and then the response that was returned for GPT. And we just keep repeating this process. By the way, I have another implementation of this where, how this one works is it automatically just takes in GPT's output and creates a data set to see if actually over time it improves itself, which from my experience it does. The only criteria for explicitly implemented criteria is to check for sorry, apologize, or however in the completion. But I've implemented another review mechanism using GPT-4. I'll be making a separate video on that when that's ready. I want to experiment with it more. Okay, so this was to save the file. And then we have another method called move to folder. This is essentially once the fine-tune job is completed, then we just take this data set and move it to all data sets, and we continue generating a new data set with _2, 3, whatever the iteration number is. Then here's the crux of this is the most important method called fine-tune, which takes in a number of fine-tunes, a number of parallel generations. Number of parallel generations is how many items we want in our data set, and number of fine-tunes is how many times we want to iterate. Here, in this case, we set it to 10 iterations of using 10 data points each time. So you can really experiment with this. However, on the other hand, it seems like OpenAI is being slow today. It's still validating files. Even if you can't take a look at that, I'll explain actually what took place through my older fine tunes. Anyway, so this is why it takes these parameters. And then we start a loop because we first want to loop through the number of fine tunes. We start at 1. That's why we're adding +1 to the number of fine tunes, because this would normally start at 0. The reason is because we want to name the files appropriately. We don't want to start from 0. And then we have a try except block, just in case if there's any errors, we want to be able to retry. Then we initialize the number of valid completions. We initialize valid completions to 0 and tries to 0. The point for tries is that so we can see, for example, we get a response from GPT and it includes the sorry, then we actually resubmit that task. So that's one try. For example, we have created a data set that has 10 data points in it, but it took us 14 tries because 4 of them were rejected due to containing sorry, apologize, or however. So that's what tries for. And valid completions is to keep track of how many valid completions we have generated. So the reason why we have to do this is due to the nature of how thread pool executor works. We just want to keep track of it and only increment valid completions when actually completion is satisfying our criteria. Then with concurrent features thread pool executor as executor, we set the max workers to 10. This signifies to concurrent features how many parallel so we are going to run 10 parallel generations, but how many of them simultaneously are going to be created is defined right here. For example, if we were to set this to 5, then we are generating 5 at a time. Okay, so there's a difference between number of parallel generations and max workers. Number of parallel generations is how many data points we want in the end, and max workers is how many of them simultaneously we want to generate at the same time. So we want to generate all of them at the same time. That's why we set max workers equal to the number of parallel generations here, in this case 10. Then we submit the generate completion method to the executor. So we create a features task list submitting the generate completion method, okay, along with the number of parallel. We submit the generate completion method as many times as there are a number of parallel generations here, in this case 10. And then while valid completions are less than number of parallel generations, remember we had started keeping track of that, we will continue to look for tasks that are being completed. And then with each task that is completed, we increment the tries, like we have tried that, right? Now we increment it by 1. We get the result, and then we check if sorry, apologize, or however exists in the lowercase versions of the completions, the responses from GPT. If so, we are going to resubmit it. We just append a new task, which is to generate completion back into the features tasks, okay? Otherwise, that's good. Then we're just going to save it to file. After that, we are going to increment valid completions by 1 because we have succeeded. And if valid completions equal or more than the number of parallel generations, which means we have reached 10 data points in our data set, then we break and then we move on to the fine-tuning part of the loop. So this previous process was to generate the data set. After that is completed, we will have a data set generated of 10 data points. Okay, now we print total tries, such as this, so how many times it took us to generate the 10 data points. And then we define the file name, and then we print fine-tuning on the file name, as you see right here. And then we use OpenAI file.create, and we create that file for the purpose of fine-tuning. And while we create that file in OpenAI Cloud, it's going to return a JSON object, and we want its ID, and we grab the ID because that's the file ID. And then we print that file ID, as you see right here, because we're going to use that for fine-tuning. And right after that, we again call OpenAI fine-tuning job create. Training file is file ID. Model is self.model name, which we have specified up here. At first, we begin with the base GPT 3.5 turbo model. However, once this fine-tuning job is created, then we get a fine-tune ID, right? And we give it a suffix. Suffix is to actually name it, so you can recognize your fine-tune. in the model name. Here in this case, tower defense, no review, and then it's going to iterate like the 1, 2, 3, 4, so you know which fine tune comes after which one. We again grab the ID from that object, and that's going to be our fine tune ID. Okay, so we are grabbing this so we can keep track of the status of the fine tuning job. So this line will start your fine tuning job, and then we are entering the next loop where we're going to continually check the status of the fine tuning job. And we call the status variable, which will be equal to calling OpenAI fine tuning job retrieve fine tune ID, and we are looking at the status of that object. And we check if the status succeeded, then we print fine tuning job succeeded, and then we break out of this loop because we no longer want to check on the status. If it has failed for any case, we print an error message. Otherwise, we sleep for 30 seconds and we continue this loop until we get a status that succeeds. Then we break out of this while loop, and then we will move on to retrieve the name of the fine-tuned model. And that we do by calling fine-tuning job.retrieve fine-tune ID, and then calling that object's fine-tuned model key. This will give us the name of the fine-tuned model. We assign it to self.model name, so it no longer is the base model. And after that, we move our dataset to the old datasets folder so we can create a new one. If for any reason there's an exception that has occurred during this try block, which we have started, then we print that error. We decrement our iteration number, and then we continue so we can try again. If this error occurs, you may end up with a little bit more than 10 data points, but that's a rare exception. I didn't actually implement a check for that. But this, for the most part, works very well almost every time. Then it's time to run. Now it's time to run our script. OpenAI key, right? Tuner is fine tuner class, and then we call that method, fine tune method, with number of fine tunes and number of parallel generations. Remember, that was the name of our fine tuner. Okay, there was some issues. The fine tuning endpoint is pretty slow today, but we have started fine tuning. Now we can actually keep track of the real-time progress of this fine tune. You can take a look at its metrics. So this is going to go on for a while, and we will be able to see what's happening. I was hoping we would be already in the iteration 3.4, but no matter, we'll keep track of it. In the meantime, I'll show you like what's going to happen. As you see here, you can see that last night I was actually training, and I had done a training for up to 7 iterations. And the suffix that I gave this was tower defense 1. And then after that, so you can see its progress. So it was converging. After that, we grab that, generate a new data set, and fine tune the next one. And that was converging as well. And then move on to the third one, and then to the fourth one, fifth one, sixth, and finally the seventh one. So after these models are generated, you can actually use them. Let me just grab it real quick, the name of the model, and come back over here, because we do have another file called call to fine tune model, because after we've created it, we want to test it, right? So I already have it pasted here. This model actually was trained using the GPT-4 review method. But now, remember, we have created our dataset based on a certain system message and a certain user message, right? As you can see right here. These are going to be present in our fine tune, so they also need to be present when we're making a call. OpenAI recommends to be the exact same, because fine tuning is really modifying the behavior of the model for a particular purpose. So now we're going to make a call, regular call, with using that model, streaming responses, and we're going to get a tower defense game and save the code to a file. You can actually run this script. Let's see what happens. Python call to fine-tune model. As you see, it's generating. I have actually realized it has converged on a style of game, which looks very similar. Anyway, let's let it generate, and then after that we can talk about it. Okay, the generation is complete, and this is what it looks like. As you see, there are some issues. First, let's look at how many lines of code it generated. This one kind of got optimized. It almost always generates around 250 lines of code. The only mistakes it makes is it never defines the color black. And sometimes it adds an extra closing bracket. So all we have to do is just fix those closing brackets and up here define a black color. I believe it's 000. And then that's it. So we can now run this. So first things first, like the fact that GPT 3.5 Turbo generated almost error-free 250 lines of code is a bit mind-boggling. And most of this code makes sense, except that it doesn't run exactly as you might expect. Let's try to run this. Python tower defense game. Yeah, see, we can actually place towers. So this actually almost is like a working game, except the towers don't fire. And we have spent some money. Let's see what happens once these go to the end. Yeah, it says game over or something, it ends. So yeah, I mean, if we keep running this, it actually really converge onto this style of game. It will keep generating new ones. So the current implementation is different than that, right? It just goes off of whatever GPT 3.5 Turbo generates and keeps going off on that. By the way, our first fine tune is completed. Right here, TD Review 1, and it has converged. You can take a look at the metrics. As you see, our loss is being reduced. Now, if we come back here, we see that we moved on to the next iteration. Something to notice is that immediately we see the effect of the fine tune because resubmitting tasks to the story has actually been reduced significantly, like it's half now, and it'll continue going like that. So it took us 12 attempts to create 10 data points in opposed to 14. Our old data set has been moved under the old datasets folder, and we have created a new one. Another thing to notice is that what I've noticed is with each iteration, the data files, the responses get longer and longer, which is to be expected for a tower defense game, which means it's actually understanding somewhat what we're trying to do. So if we refresh this, we should see another fine tune has been started. So this process is going to repeat for as many times as we have specified here. Again, remember to check my website, www.ecohive.live. I have over 200 projects here, everything from LangChain to fine tuning, and my agent that I built, Auto AGI, which you can actually voice control it with. Voice control Auto AGI. So I do a lot of interesting projects. I like to experiment and give you fresh new ideas. I also have some full stack web app building videos, quite a lot about Streamlit, function calling, and feel free to check it out. And if you do decide to become a patron, I highly appreciate it. This website also makes it easy to find the code download links. So let's do a quick experiment. Let's get back to our call to fine tune model function and actually just replace this to call the base model, just to see what base model would be creating, so we can have an idea of comparison point to see what we can expect. So first things first, I'm glad. So yeah, it's writing some code. Let's see what happens. Okay, it has written some code, and we can see that it's very short. See, it's not even 100 lines of code. This is what you'll get out of the base model. Let's try it again. Okay, this time it's apologizing. Let's see. I apologize for any inconvenience, but creating a, so it still created some code, but it's saying that it's not possible. So again, it's less than 100 lines of code. Let's run it one last time for good measure. Again, we have 100 lines of code. And if we actually run these code files, I don't think they would work in any meaningful way. Yeah, see, that's it. So the point is, I guess, by comparison, I mean, fine-tuned model is able to generate up to 500 lines of code. So you'll be the judge of whether if that's a good thing or not. as our fine tunes are being concluded, we can actually test them to see how they perform as well. While your fine tunes are being completed at any point in time, you can actually come over here and grab any one of the model names. For example, this is our third one, and actually test it. You can also grab these from the playground. They should be at the bottom, but somewhere you should be able to tell it by its name. And if you select the fine-tune model here, and if you go to view code, you can also find the model name from here. After grabbing the model name, you can just replace this right here and actually run it to see how it's performing. In the meantime, we have started our fourth iteration of fine-tuning. And as you see, we no longer get any resubmitting of the task due to sorry apologizer. However, it only takes us exactly 10 tries to get 10 data points. That means our fine-tune is improving. Let's take a look at the game we've generated. You can already tell that it's generating close to 300 lines of code. Only problem here is this extra closing bracket. That was it. Let's run this and see if it actually works. No, it's getting an error. So we're going to continue fine-tuning and check it at the end as well. But this is how you can actually see the performance. But, if from the generations which we've seen from the base model to this, there's a night and day difference. I mean, this is almost error-free, 300 lines of code. It doesn't work, yes, but this is, I think, quite an achievement to begin with. And also, we are no longer needing to create the dataset with any resubmitting of the task. Some of you may remember I actually had an auto prompt experiment in which I was trying to get GPT 3.5 Turbo 16K to generate more lines of code by iteratively trying to improve the prompt. You can watch this video, it has many interesting ideas in it, but it wasn't really working. So, if nothing else, to get GPT to generate more than a certain amount of code for a certain number of lines of code is a challenge on its own. So if you like, check out this video as well. So the fact that we are getting it to generate 300 lines of code by just fine tuning is quite an accomplishment, like I said. Anyway, I'll be back to see where this goes. So let's take a look at our process. Currently, we're training the final iteration. Our 9th iteration had been trained, and seemingly it's converging. And I have gone ahead and called that model by grabbing the model name and created a few examples. So it really creates concise, elaborate code. This is almost 250 lines of code. However, I had to clean up some things. As you see, the player and the tower is not defined here, but this is what it looked like initially. So this is something I noticed with fine-tuned models. You see, it seems to be a lot of errors, but these errors are closing bracket errors. So they're easy to fix. You just delete the extra brackets. And sometimes it leaves out some of the definitions, such as enemy list. Those are also easily fixable. But at the end of the day, take it for what it's worth. This is self fine-tuning without any kind of feedback, except for we are taking away the completions which include sorry, apologize, or however in it. I'm not going to wait for the last one to finish it, although it is converging. So does it produce? Let's run one more time. Let's see, so you can see it producing code. Does it still create? Does it create a fully working tower defense game? No, but I'm going to keep working on it. I will make another video with the GPT-4 reviewer. We'll see. We'll try to get it working, and see where this takes us. So I think this was a fun experiment. I hope you enjoyed it. Let's take a look at this again. Yeah. So see, it creates. So the errors are only, like I said, bracket related, not only, but mostly. And then it has some definition issues, such as it's not defining all the game elements. But I think this is an improvement. This is the most success I was able to have with tower defense games, I believe. I'll continue experimenting. Thank you for watching, and thank you for being a patron. If you'd like to talk about large language models, join our Discord. Link will be in the description, and I'll see you in the next video.